There's one technique that Chinese engineers used when building this vessel, and it completely turned the entire global offshore energy industry on its head. Nobody knew the problem could even be solved, until the answer showed up right in the middle of the ocean. A vessel weighing thousands of tons slowly rose out of the water on 4 steel legs and held still. Waves crashed beneath its hull. It didn't shift a single centimeter. And this is not a special effect. This vessel is called the Jianhanping 5. It was built for one purpose: to install wind turbines so enormous that no other crane in the world can handle them. We're talking about blades longer than a football field, towers as tall as a 60-story skyscraper, and a crane capable of lifting 1,800 tons nearly 200 meters above the surface of the water. How is any of this even possible? And why can a single one of these turbines power 55,000 homes from just one spinning rotor? That's exactly what we're going to get into. And we'll also cover the hidden dangers lurking beneath the ocean floor. The storm that nearly wiped out an entire wind farm, and the computer system that manages everything happening on board without a single human touch. Let's start with the barrier that had stopped every engineer on the planet for years. In the offshore wind energy industry, there had long been an unspoken rule. Turbines more powerful than 18 megawatts were too dangerous to install in open water. The problem wasn't the turbines themselves. The problem was the vessels that had to lift them. The industry's logic had always pushed toward bigger. The more powerful the turbine, the more electricity from fewer installations. Fewer trips, fewer cranes, lower costs. Size was always the goal. But once a turbine's output crossed a certain threshold, the components became so heavy that a conventional vessel simply couldn't lift them without risking a capsize. Picture this. A crane boom swings a load weighing several hundred tons out over the side of a vessel floating in open water. At that moment, the center of gravity shifts dramatically. One wave at the wrong time, and a multi-ton structure turns into a massive pendulum. Engineers in Europe and North America eventually settled on 18 megawatts as a practical ceiling. Some companies spent years perfecting machines right at that limit, not because they didn't want more, but because the vessels simply wouldn't allow them to go further. It became an unspoken law of the industry, an invisible ceiling that nobody dared to break through. When China announced a turbine nearly 50% more powerful than that limit, the professional community was stunned. The turbine itself was a remarkable achievement. But here's the paradox. Building a record-breaking turbine turned out to be easier than solving the next problem. How do you lift it onto a tower in the middle of the ocean, hundreds of kilometers from shore? You couldn't just take a regular crane and make it a little bigger. Engineers had to rethink the vessel itself, from scratch. The answer was the Jianhanping 5, commissioned in August 2024. The vessel is 135 meters long and 50 meters wide. In terms of footprint, it's a city block with a massive crane sitting on deck. At first glance, nothing looks unusual. The main secret isn't visible until the vessel arrives on site. Running along the sides are 4 massive steel legs. On command, they drive straight down through the water column all the way to the ocean floor. Once the legs make contact with the seabed, hydraulic systems begin lifting the entire hull upward. The vessel literally climbs out of the water like an elevator riding 4 columns. After that, it's no longer a ship. Waves pass beneath the hull. The vessel doesn't tilt, doesn't drift, doesn't respond to the swell, not at all. Engineers call this converting into a stationary platform. Put simply, 27,000 tons of steel become a temporary island in the middle of the sea. People who see this for the first time are convinced they're looking at CGI. A vessel this size shouldn't be standing on 4 slender legs while the sea rages around it. But that's exactly what happens. The crane needs an absolutely stationary foundation. If the deck shifts even a few centimeters at 200 meters up, that translates into meters of swing. By lifting the hull above the waterline, the Jianhanping 5 completely removes the ocean from the precision equation. But this is where things get unsettling, if you know the details. Driving steel legs into the ocean floor sounds straightforward. In reality, the seabed is unpredictable. Beneath a thin, firm crust of compacted sand, there's often soft silt, loose sediment, or even underground water pockets that are invisible from the surface. When a heavy leg pushes down expecting solid ground and instead punches through a weak layer, it can drop several meters in a matter of seconds. In marine engineering, this is called leg punch-through. It has caused real accidents around the world. Uneven sinking of one leg creates a dangerous list, forcing crews to abandon ship in an emergency. That's why preparation for each installation begins long before the vessel arrives. Geologists scan the seabed using sound waves and collect physical soil samples by drilling test boreholes. Before the legs even begin to lower, engineers know exactly what's hidden beneath the surface. And during the descent, the onboard computer tracks the pressure under each of the 4 legs in real time. If one starts sinking faster than the others, the hydraulics instantly redistribute the load. The system works like 4 robotic legs, each one constantly checking its footing and silently correcting itself before any human could notice a thing. Once the vessel is standing steady above the waves, the most impressive part begins. The turbine being installed by the Jianhan Ping 5 is manufactured by the Chinese company Dongfang Electric. Its specs are hard to take in all at once. The central hub where the blades attach sits 185 meters above the water, higher than most skyscrapers. The 3 blades sweep a circle 310 meters in diameter, roughly 10 football fields lined up end to end. A single turbine generates around 100 million kilowatt-hours of electricity per year, enough for 55,000 homes, and eliminates the need to burn approximately 30,000 tons of coal. One machine replaces a dozen smaller installations. That's exactly why engineers were so obsessed with breaking through the 18-megawatt barrier. To hoist the generator unit to the top of the tower, the crane holds nearly 1,800 tons of steel, nearly 200 meters above open water. At that height, even a moderate gust of wind puts enormous stress on the metal structure. But there's another problem that almost nobody thinks about: sunlight. When the sun heats one side of a steel tower more than the other, the metal expands unevenly, and the top of the structure can drift off-axis by several centimeters. On real offshore projects, this has forced crews to stop work and wait for a nightfall so the metal could cool and realign. On the Jianhan Ping 5, computers continuously monitor sun intensity, air temperature, and wind speed, automatically adjusting the crane's position so that invisible shifts don't turn into costly delays. When the crane moves a heavy load to one side, the vessel would normally list, say, the same way a boat tips if a passenger leans over the railing. The solution is active ballast management. Large tanks inside the hull fill with seawater or drain in a matter of seconds. The moment the crane shifts a load to one side, pumps move hundreds of tons of water to the opposite side, restoring balance before any list becomes noticeable. The system doesn't react to a list that's already started, it anticipates it, based on the crane's planned movement, and acts ahead of time. All of this, pressure monitoring under the legs, ballasting, corrections for thermal expansion of the tower, generates a stream of data that no human crew could process manually. That's why the vessel is equipped with an intelligent control platform that coordinates the ballast tanks, positioning, and crane operations as a single unified system. The platform analyzes water density, wind force, and other parameters in real time, automatically optimizing fuel consumption. Roughly 20% less compared to similar vessels without this kind of automation. Navigation and crane control run on a closed network, completely isolated from the internet. Hacking is ruled out by the very architecture of the system. 3 independent positioning systems operate simultaneously: China's satellite navigation, GPS, and laser sensors. If one fails, the other 2 immediately take over. And if something goes wrong despite all those safeguards, the captain turns a single physical key and switches the entire vessel to manual hydraulic control in a matter of seconds. But there's one adversary that pushes the entire system to its absolute limits. The South China Sea is one of the most storm-prone regions on the planet. In September 2024, Typhoon Yagi caused serious damage to older wind turbines in the region, making it vividly clear just how destructive these storms can be. They snap steel towers, shred blades, and knock entire wind farms offline for months. When a typhoon approaches a turbine installed by the Jianhan Ping 5, a protective sequence launches automatically, without any human input. The 3 massive blades rotate edge-on into the wind, like a flag turned sideways. It offers almost no resistance to the airflow. This dramatically reduces the load on the entire structure. The vessel itself raises its hull even higher on the hydraulic legs, so that large waves pass beneath the hull without striking it. A turbine that protects itself. A vessel that escapes the force of the storm by rising above it. That combination allows them to survive a storm that would have destroyed equipment built just a few years ago. When the weather clears, the automation quietly returns everything to operational mode, and the turbine starts generating electricity again with almost no interruption. A vessel that rises from the ocean on 4 legs, a crane that lifts a skyscraper in open water, a turbine that survives a super typhoon. All of it is the result of one decision: refusing to accept impossible as a final answer. If this kind of engineering impresses you, hit the like button, subscribe to the channel, and ring the bell so you don't miss the next video. Let us know in the comments, which detail about this vessel surprised you the most?